Hello, ladies and gentlemen, and welcome back. Welcome back. Root Beer here with the 2015 Canadian Intermediate Math Contest. That's a CIMC aimed at sort of the beginning levels of high school. Grades 9 and 10 is sort of what we're shooting for here. And we're on question number 2 of B part. And you'll remember B part is the written solution questions. So it's not about the final answer. Now it's about getting marks for our method and showing all our work and properly justifying the statements that we write down. Okay, so let's see what question 2 has to offer, although hopefully you've had a chance to look at it for yourself. Give it a little try. So, question 2, I noticed right away it's got 3 parts. So then we're on to the next page with question number 3. So, Alistair, Conrad, Emma, and Selma compete in a 3-sport race. They each swim 2 kilometers, then bike 40 kilometers, then finally run 10 kilometers. Also, they each switch instantly from swimming to biking and from biking to running. So there's no transition times we'll need to worry about in this question. Okay. A part. Emma has completed 1/13 of the total distance of the race. How many kilometers has she traveled? Okay. Well, we need 1/13 of the total distance. So what is the total distance? Well, they swim 2 kilometers, bike 40 kilometers, and run 10 kilometers. So we add all that up. That's the total distance of the course, and we divide that by 13, and that'll give us 1/13 of the total distance. Okay. So 2 kilometers, biking for 40, and then running for 10 kilometers. And in total, that gives us 32 kilometers. 1/13 of 52 kilometers. Well, fortunately, 52 is divisible by 13. It's going to be 4 kilometers, although if you needed to, you can use your calculator. So I'll make a little statement there. Who was it? Was it Emma, I think was her name? Yeah, Emma has traveled 4 kilometers. Okay, great little introductory question. It gets us thinking about the distances and make sure we understood the race that's going on here, the 3-sport race. Okay, we expect B to be a little harder. Conrad begins the race at 8 a.m. We're probably going to get into times and speeds now. In fact, if I look ahead, I see 24 kilometers per hour, so we're probably going to talk about times and speeds a lot. So, Conrad began the race at 8 a.m. and completed the swimming portion in 30 minutes. That's pretty good, swimming 2 kilometers in 30 minutes. I'm not a professional swimmer, but that sounds kind of impressive. So, that's half an hour, 30 minutes. Hopefully that's something you guys can convert. So I guess he was did 2 kilometers in half an hour. That sounds like he's going 4 kilometers per hour when he swims. I don't think I swim that fast. Anyway, Conrad biked 12 times as fast as he swam. So we'll need to work out how fast he swam, which I just said was 4 kilometers an hour, but we'll have to show our work for that. And he ran 3 times as fast as he swam. So if we know how fast he swam, multiply it by 3, that's how fast he ran, and multiply it by 12, that's how fast he biked. What time did he finish the race? Okay. So, what I'm going to do for this question, I'm going to break it down, and I'm going to say, okay, he started the race at 8 a.m. How long did it take him to finish? How long did it take him to go the 2 kilometers? Okay, it took him half an hour. They gave us that in that question. And using that information, 2 kilometers in half an hour, we can figure out how fast he swam. Multiply that by 12, get how fast he biked. Now we know he started biking at 8:30 when the swimming portion ended. And we know how long the bike path is. It's 40 kilometers. If we know how fast he was going, those 40 kilometers, we can figure out the time it took him to do that. We'll add that on to the 8:30, and that'll tell us when he finished the bike portion. Then we can do the exact same thing, using how fast he swam, which we already calculated out. Multiply it by 3 to figure out how fast he ran. We'll know when the bike portion ended, so that's when the running portion instantly starts. and then we'll know how long. We know how long the bike or the running path is. It's 10 kilometers. Do 10 kilometers divided by that speed we worked out, and that'll tell us how long he was running. And so from the start to the end, we add on that time, and that tells us when he finishes the race overall. So that's the plan of attack. So we got some things to calculate. First of all, how fast was he swimming? Because that'll tell us how fast he was running and how fast he was biking. Okay, so let's go back to our notepad. I think his name was Conrad. I think they gave us 4 people in the question. Swam. So I'm guessing the last one probably involves a race or something, or seeing who finished first or something like that. So he swam 2 kilometers in 30 minutes, which I'm converting to hours. I mean, you could do kilometer per minute. I don't think anyone's going to fault you for that one, but I'm going to keep it in half an hours. Just because I looked ahead and I saw 24 kilometers per hour, so maybe we should keep everything in kilometers per hour. So the relationship is distance, so speed is distance over time. And you can rearrange that however you want. You can get the distance traveled by multiplying speed and time. You can get the time it took by taking the distance and dividing by speed. All right, we want Conrad's speed. How fast did he swim? Conrad's swim speed is 2 kilometers per the half hour that he took. And that, as I already said, I did that in my head, is 4 kilometers per hour. That's how fast he was swimming. Now we know, because they gave it this to us, Conrad's biking speed is 12 times that. That's going to be 48 kilometers per hour. And we know Conrad's running speed. And the question said it was 3 times as fast as he swam. Well, we know how fast he swam, 4 kilometers per hour. That gives us a total of 12 kilometers per hour. All right. So, we have his biking speed, we have his running speed, we have his swimming speed. Now what we can do is we can work out how long did it take him to do the swimming portion. Well, we already know that. But how long did it take him to do the biking portion? How long did it take him to do the running portion? Then we add up all those times and add it on to his start time of 8 a.m., and we can figure out when he finished. Okay, so we actually have 2 times to figure out, the time it took him to bike and the time it took him to run. All right? So we tell everybody what formula we're using. Time is distance over speed. We just rearrange the speed equals distance over time formula and we get this. So Conrad's, let's do biking. His bike time is, well, how long was the bike path? It was 40 kilometers. Okay, we noted that with Emma's question. And what's the speed? Well, we just worked that out, 48 kilometers per hour. Okay, the kilometers are going to cancel out. The hours will come back up on top. And we'll be left with 40 over 48. Both of those have a factor of 8, so we can remove that. And we'll get 5/6 of an hour. Okay. If we wanted that in minutes, we could convert. There's 60 minutes in an hour. We'll get 50 minutes. But we'll convert that in a moment if we need it. Okay. Conrad's run time. Okay, it's the total distance of the running track, which is 10 kilometers, over his speed, which is 10 kilometers per hour. Okay, so the hours comes up on top, the kilometers cancel out, the units cancel here, and we're left with 10 over 12. Now both of those have a factor of 2, so it's 5/6 of an hour. So in total, Conrad's race took a half hour, plus 5/6 of an hour to complete the bike, plus another 5/6 of an hour to do the run that we just worked out. And this turns out to be, we can make this a 6 at the bottom by putting a 3 up here. We'll have 3 plus 5 plus 5, that's 13 over 6 hours. Another way to write that is 2 hours and, 2 1/6 hours. And 1/6 of an hour is 60 minutes, so 10 minutes. So 2 hours, 10 minutes. That's how long Conrad's run took. So he started at 8 a.m. After 2 hours, so we're not done yet, but after 2 hours, it's 10 a.m. We can easily add the hours, and then we have, after another 10 minutes, we have 10 a.m. He finished at 10 a.m. Okay. And I think that's what we were asked for, right? At what time did he finish the race? I'm saying it's 10:10. 10 in the morning, or 10 past 10 in the morning. Okay? So C part. Alistair and Salma also began the race at 8 a.m. Okay, I hope Emma did as well. Or maybe she's got a bit of a handicap and they gave her a nice little extra time to start. Or maybe she's that much better than them all that she gave them the head start. Who knows? So Alistair finished the swimming portion in 36 minutes, a little slower than Conrad. And then he biked at 28 kilometers an hour. Salma finished the swimming portion in 30 minutes, so she was tied with Conrad. So a little faster than Alistair as well. And then she biked at 24 kilometers per hour. Alistair passed Salma during the bike portion. What time did Alistair pass Salma? Ooh, okay. So, let's just think about this. When Alistair's the slow one. When he starts his biking, whatever time that is, 36 minutes after 8 a.m., I guess. When he starts his bike time, when he starts biking, Salma is already 6 minutes ahead. Now, she's gone a certain distance in 6 minutes. Maybe I should figure out what that distance is. So she moves at 24 kilometers per hour, and 6 minutes is a tenth of an hour. So I could probably figure out, she's probably gone 2.4 kilometers. I guess just working it in my head. I'll do the math in a moment. So she's already 2.4 kilometers ahead of him. Then Alistair eventually catches up. He catches up at some distance later. So she's 2.4 ahead. Then we add on some other distance, the distance it takes for Salma to go until Alistair passes her. So in the time that she's gone, let's say, D kilometers, Alistair has now gone D plus 2.4 kilometers. And we can work out when that should be. Okay, when those happen to be the same point. Okay. Then we can figure out, well, if we know D, we know that distance, and we know when Alistair started biking. So we can figure out the time it took him to go, 2.4 plus D, and add that on to the 836, and we should be able to tell when Alistair passed Salma. Just thinking through it. If we need to, we can draw a picture, and that's probably what I'm going to do in a moment. Okay, but I'm going to write down some details here. Has Alistair got 2 L's or 1 L? 1 L, okay. Don't want to spell someone's name wrong, even though I'm pretty sure I do every once in a while. So when Alistair starts his biking, Salma is 6 minutes or 1/10 of an hour ahead. So Salma has gone, well, we know her speed, and we know the time. If we multiply that, we know distance is equal to speed times time. And that's the only way it'll work. Speed is kilometers per hour, and time is hours. The hours have to cancel out to give us kilometers. So her speed is 24 kilometers per hour times 1/10 of an hour. So we should get 2.4 kilometers. So if we use S and A here, just for our little picture, Alistair starts here. Salma's already gone 2.4. That's where she is. Then she, I don't know, let's use the purple here. She keeps going, but Alistair's going faster. He's going 4 kilometers per hour faster, and he eventually makes up not only the 2.4, but catches up. And so she's gone some distance D, and he's gone 2.4 plus D. So I'm going to say, so let D equal distance Salma has gone by the time they pass. So she's already ahead by 2.4, and then she travels another D distance, and in that time it takes her to do that, Alistair has caught up. Okay. I need to know this distance. I need to know the distance that they've gone by the time they pass. That's what I need to figure out. If I know that, I know Alistair's speed, so I will know how long it took for him to catch up. That's the only way I can do it. I know a speed. To get a time, I need a distance. So I can do distance over speed. So that's my thinking. So I need the distance that Alistair goes. Okay? And so Salma has also gone a particular distance, and it turns out these are the same. So, in the time it takes Salma to go D, Alistair has gone 2.4 plus D. So, we can take the time it takes her to go D. We can do the distance D over her speed, and that should be the same as the 2.4 plus D over Alistair's speed. Those should be equal amount of time. Okay? And that's the time that they pass each other. Okay? So actually, do we even need D? We'll probably need D, but we might not, because what we want is that time there, the 2.4 plus D over 28 kilometers per hour, or the D over 24 kilometers per hour. The time is what we want, really. Okay? So Alistair travels 2.4 plus D kilometers in the time it takes her to go D kilometers. We can set up an equation representing that. Our time in the middle, which is the thing that we actually care about, it's the distance that she went, because time is distance over speed, at 24 kilometers per hour. Okay, and how far did Alistair go? 2.4 plus D at 28 kilometers per hour. All right, so we've got a single equation here. It's got D's in it. We can probably rearrange and get a linear thing. So we get D over 24, getting rid of the units. We'll bring them back in later. 2.4 plus D over 28. So I can multiply by 28 times 24 on both sides, and we'll work out something like this. So we get 28D here, and 24 times 2.4, I think that'll be 57.6, just because 24 times 24 is 567. We divide by 10, but I'll get my calculator out and double check it. Oh yeah, that feels good when you get that right. So 57.6, 24D. So let's bring all our D's onto one side. We got 4D over here. It's 57.6. And actually, we probably could have just kept the 24 there, because now we have to divide by 4. And we'll get 14.4. So that's the distance. That's the distance Selma goes. So what we're going to do is we're going to want the time it takes for this to occur, and add it on to the 36 minutes that have already passed. So we can get this time either by doing the 2.4 plus d over 28, or d over 24, doesn't matter. They're both going to be the same. That's the point of the equation at the top of the page. That'll be divided by 24. We'll get 0.6 or 3/5 of an hour. And that's going to be 36 minutes again. Interesting. So it's been 36 minutes, because that's how long it took Alistair to finish the swimming. And now our calculations say another 36 minutes to get Alistair to catch up. So it's 36 plus 36, or 72 minutes. After 8 a.m., well, after 60 minutes, that's a full hour, so it'll be 9 a.m. And then what's left over, another 12 minutes, so it'll be 9:12. And we conclude with a final statement. They pass at 9:12 in the morning. All right. Not bad at all, and that does it for C part, which is the last part in question number 2. So we just have the one question left to go on this contest, and it's also another 3-parter, and it's going to be question number 3. We're going to deal with that in the very next video, and that'll finish off the contest, and we can, as the intermediate, so we'll set our sights up on the senior for this year as well. But that's thinking way ahead. Join me in the next video for question number 3 in B part.